Hi, I'm Faiz Chaudhary, and this project is my assignment 2 for web mining and recommender systems. So, my project is titled Beer Rating Prediction using the BeerAdvocate dataset. The goal of this project was to take a large real-world review dataset, analyze it, and build predictive models to estimate user ratings using techniques we covered in class, basically. So let's first move on to dataset overview. For this project, I used a BeerAdvocate review dataset from the Stanford Snap repository. I worked with a subset of roughly 200K reviews spanning 15.5K almost unique users and about 8.2 thousand different beers. So pretty diverse beer catalog. Each review contains rich, structured data, including beer characteristics like name, style, and alcohol content, user identity, multiple aspect ratings, an overall rating, a written review, and a timestamp. So ratings ranged anywhere from 0 to 5, which makes this well suited for regression-based prediction. So as we move on, we can see what each review contains. I wanted to just give a quick breakdown so we kind of understand what we're getting into here. Basically, what we know is that each record in the data set will contain 4 main components. So this is first beer information, including the beer's unique ID, style classification, and its alcohol by volume, or its ABV as we'll refer to it. Second, we look at the user profile, which is going to give us their name and their identity is going to, identify the reviewer. Third, we have detailed ratings where users can actually score based on things like appearance, the aroma, the palate, taste, and also just give an overall rating out of 5, right? Next, we review content, which basically means it's going to have free text content and a timestamp. So it can be used for NLP or temporal modeling in future work. That's one thing to keep in mind. Next, we move on to exploratory data analysis. So I started by performing an exploratory analysis to understand overall rating behavior better. So the distribution, as you can see, is positively skewed with a mean rating of, I believe, about 3.87 out of 5, meaning most users tend to give fairly positive ratings. About 77% of all reviews are above 3.5, which reflects a common bias in review data sets, actually, which is that people usually review products that they already expect to enjoy. This confirmed that we should be careful interpreting low ratings statistically since they're a lot rarer. Okay, moving on. We are looking at beer style patterns. We examine which beer styles appear most often in the dataset, and these are some of the most frequently reviewed styles that we have based on my findings. First, we have American IPA, most frequently reviewed, as you can see, reflects the craft beers, its emphasis on hoppy and bold flavors. We have American Double Imperial Stout, which high alcohol, dark and complex beer, very popular among enthusiasts. You have the American Double Imperial IPA, stronger than a regular IPA with intense hop character, and then you have your American Pale Ale, approachable. It's kind of like a gateway to craft beer, as I wrote down here. So this analysis kind of gives us the idea that beer style is likely a strong predictive feature. So moving on, I have a little bar chart here of style rating correlations. So when I compared average ratings across beer styles, I found extremely clear differences. For example, styles like rye beer and imperial stout tend to receive average ratings above 4, while styles such as fruit and vegetable beers receive like noticeably lower average scores. This indicates that style doesn't just affect popularity, but it also strongly correlates with user satisfaction. So this finding was one of the main motivations for including beer style as a categorical feature in the predictive models. Next, we'll look at predictive modeling approach. So the predictive task in this project is to actually I'll say it this way: given information about a beer, predict the overall rating that a user will give it. Right? That's what the point of what we're doing here is. So to evaluate model performance, I split the data set into 160,000 reviews for training and 40,000 reviews for validation, right? I used mean squared error MSE as an evaluation metric, which measures the average square difference between predicted and actual ratings. So, and then as you can see, this was my optimization goal to minimize MSE on validation sets so we can ensure generalization. I just gave a little formula for that there. Next, we're going to talk about feature engineering. For this assignment, I intentionally focused on simple, interpretable, content-based features. So the two primary features that I wanted to look at were alcohol by volume, ABV, as a numeric figure, and beer style treated as a categorical figure and one hot encoded. So pre-processing involved, as you can see, converting ABV strings into floating point numbers, one hot encoding beer styles, and dropping rows that contain missing values for these features. So the rationale is that ABV captures objective beer strength, while style encodes it captures flavor category and user expectations, basically. So you kind of get a bit of a comprehensive look with those two features was my idea, basically. Next, we are going to look at three models of increasing complexity that I evaluated. So we have first global mean baseline, which predicts the same average rating for all beers. This achieved an MSE of 0.478. Next, we have a standard linear regression model using what we said are ABV and beer style, right? And this reduced MSE to 0.444, showing that even simple content features add predictive power. Finally, I trained a ridge regression model I wanted to try, which added L2 regularization to prevent overfitting from high dimensional one hot features. So this achieved the best performance, as you can see, 0.417. So this does demonstrate that regularization significantly will improve generalization. So that is something that we can take away from here. Next on, and progressive as we saw. Next on, we will look at conclusion. There are several key conclusions from the project that we want to take away. I think first, even very simple content features like the beer style and the actual ABV are highly predictive of user ratings. Second, regularization is critical when working with sparse categorical features. It's very important. Third, I feel like it's really important that beer style itself turned out to be one of the strongest predictive signals. It's something that we see in this particular data set is very important, right, with these ratings. However, there are clear limitations. And here, let me move this over so we can look at some of this. Firstly, I'll say that we didn't include user-specific preferences. Don't mind my watch beeping over there. We did not use review text, nor did we consider temporal effects. So future improvements can include adding user and beer bias terms. We can include applying matrix factorization, using TF-IDF or text embeddings, and incorporating actual time-aware features. I think that would be a really important, a really cool one to look at. Even with, I would say, in my opinion, even with these limitations, the project did show that regularized linear models can already form a strong baseline for large scale rating prediction. Thank you.